Hello, this is Alexander McGurk, doing a screencast for the repeat ca1 in data structures and games, continuing on from the first half. So where we left off, I was explaining the remove function, the way it pushes everything back to keep order of an array. Once it's done that, it'll just decrement num elements because you've removed something, a simple output message. The next was a little display function I set up just for myself to be able to display whatever's in the array so I could see it, because it was becoming too cumbersome to continuously write that out in the main here. A clear all function, this function clears all elements inside the array at the point of call. Like I said, I wasn't sure on how to get the garbage data, so I just went through a loop of the array and set everything to 0. I know 0 isn't the proper function, and I'm thinking now if I could copy the method of resizing somehow. Resizing gives you the empty garbage data, so maybe some method of creating, deleting this and creating a new array and send the pointer to that, and so that way the new array would have loads of empty spaces, if you know what I mean. Make a new one, delete marray's current piece and set marray's pointer to that. I might try that and have that in the finalized piece. If I do, I'll leave a comment in the screencast URL text page saying so. Regardless, that's how that happens, and then a little output message saying so. Right, the search functions. The search functions are a function that searches for a particular element and gives back an index location. The first one here is the linear search method. This searches by going through every element until the correct one is found and takes in the element to be located. So this function here is of complexity order type n. The duration of time to complete this code varies directly on how much data is being processed. So it's nearly, if there's twice as much data, then it's going to take twice as long, because this has to search through all of them. So it would be like, I think the appropriate example is a phone book. If you're searching for a name starting with B, you have to go through it all from the very beginning, all through the A's and such, until you find the correct one you're looking for. The method of doing this is, first we have the input coming in. You have an index set up to 0, then checking while the index is less than m size, just to keep yourself in the loop. We have a little if else here. If the array's current index is equal to the input that you're looking for, then the simple success method, or success output, and then the location of wherever the input is and just outputting whatever the index is, -1 because of the way that it reads in method, and then a break. Otherwise, if this doesn't happen, then I'll just keep going to index plus, continuously going. I think I could put an error message in around here so that if it doesn't do if, because if comes out on its own break, and then else doesn't work and it just goes right through, then you could say a little error message saying that it didn't pick up anything. So the other search method is bin search or binary search. This binary search method searches for a specific element by using a higher or lower method of narrowing down to the answer. So say you have 9 boxes or 9 spaces. It will look at the middle space, number 5, and it will see is what you're looking for higher or lower than what's here. And if it's higher, then it will look at the higher half, and if it's lower, it will look at the lower half. And it works that way. It will keep narrowing things down until it finds the actual answer you need, which is why ordering is such an important thing in this, because that kind of search would search looking for something based on like alphabetical or numerical order. This type of function is complexity, or its complexity is of order log, I'm not sure how to actually say this, but log 2n. This code also varies with the size of the data being passed in, but it's much more, it's much more effective when being used for larger searches. So all I'm trying to say there is that, sorry, um, basically it does work the same as the other one. You know, it comes down to the time it'll take, comes down to how much data is being passed in. But in a scenario where you have a few thousand elements, it's much faster at narrowing them down, because each time that you go through a cycle, it's just halving how much you actually have to search for. So this does come a lot faster than the linear search up here. Method of doing this, I have an index set up, a max which is set to num elements, middle which is max divided by 2 to get the actual middle point, and then an iteration initially set to 0. Use the log method here, which gives the number of times the item can be divided by 2, because it's a shorter method. The original line here was a much longer, complicated code. And then set a bool for located to false. So this goes through it while the iteration is less than the maximum possible iterations and located hasn't been found. We'll do this if else mode. If the input is greater than or equal to the array's middle, then the index equals middle, middle equals middle plus max minus middle over 2. That's just to narrow it down and such. Else the max equals middle, middle equals blah blah blah. So that's breaking it down. So basically, if it hasn't been found, make the new maximum what the original middle was, and then loop through continuously and keep doing it. And so that's narrowing down the search each time. Then if array index is equal to input, you found it, so set location to true, which means it'll come out of this while loop. And else just keep doing the iteration over and over. Now, once you're out of that while loop, if this just to check and make sure it worked, if the max iterations wasn't caught, then that means then the only other way to get out here is that you found it. So that's a success, saying that you found the whatever input and its location is where. Otherwise, it means that it came out as an error. So just a little error message there. Okay, the next function was read unordered. This function was to read an unordered array from a file and put it into order. It takes in the name to the file and read from. So you have p file here. This one I had initial problems with the first time around. A friend in college showed me how a method of fixing this up. So first you clear everything, clear the array of anything that's already there, because you don't want stuff overlapping and such. Set up a data type of data and an if stream for like fin with the name of the file that you're going to be opening. Make sure that there's nothing open already, so just as an extra safety check, close anything that's already there. Then open the file name that you've passed in and use the push function, which includes a resize, as I showed earlier, to enter a new element into the array. So you're basically pushing everything from that into data here, and you use then the data to be pushed. So that's how you're checking that there is data and such. Keep going like that, and then when that's all finished, do fin.close to close the file again. Then return true just to say that it's been done. I'm not sure if I did actually point that out, but up here in the push function, yeah, the array will check if the index is in the push function. It'll check to see that there's enough space, and if there is enough space, then, or if there isn't enough space, sorry, it'll call the resize function to add on another space, and they'll do that for as many times as necessary, depending on how much you're pushing in. Sorry. So yeah, that's the read function, and as you saw with the text file earlier, that's working fine. So the next one was a write ordered. This was a function to take an array and write it to an external text file. So you just take in the name of the file you're writing, and then you have out file here equals 0, int written equals 0, out file equals f open, and you have to set f open to the name and wb to write binary. Then that's just checking to make sure that it opened all correctly. If it equals 0, then it didn't, so return false. Set written to fwrite, and it writes out the array size of the data type, the m size, and the out file. Once all that's done, simply close the out file. Again, check if ren is not equal to m size. If it is, then there's been an error, so return false, it didn't work. Otherwise, everything went fine, return true. The last function I had was just something to make the read and write functions a bit easier to get. Takes in a check word of which to call read or write, and then the text file name. Should call the read and write functions, give back a boolean true or false, and display an appropriate output. Takes in which method to call read or write and the name of the file to read from or write to. This was just a simple bit for when you're calling read or write. I'll show you here. See, look, if you're calling the testing to see if you're the right ordered work, then you call elements.readWrite. You put in write, which means that you're trying the right one, and then you put in the text file name that you're going to write to. And the same here for read. If you want to read something from a file, then you put in read and the name of the text file you're going to read from. So that's just two big ifs stayed. If pcheck equals read, then do the call read unordered by the file name. Make sure that's true, and if it's true, success. If it isn't, then error. And the exact same for write. If the pcheck word is write, then they want to do write, so call write ordered. And then if write ordered by the p-file name equals to true, success, you did it right, or it worked. And if write ordered is false, then it didn't. So that's my CA. Again, like I said, I'll look into trying to recreate a clear all here. I'm presuming now, just thinking as I've done this screencast, that I could do something similar to the way I resized, in that I could make a completely new array which would be full of empty spaces, and then just delete this old one and set pointers to that one instead. I'll give an attempt at this. If it does work out, I'll make note of it in the little text file with the screencast URL. I've been having some problems trying to commit and push these up to Bitbucket, so I'll just make a blank a new Bitbucket repository and upload the whole thing as the individual files. That's all then. Okay.